The paradigm has shifted in the wireless threat landscape for 2024-2025. Expert analysis reveals an evolution from cryptographic breaches to attacks on logic and infrastructure. Key changes include the move from WPA2 to WPA3, a focus shift to control systems, and the mandatory security mechanisms introduced by Wi-Fi 7. 3 key changes define modern wireless security. The era of Wi-Fi password cracking is ending, with the fight now on protocol logic and management infrastructure levels. We see 3 fundamental trends: protocol hardening, logical exploitation, and infrastructure vectors. WPA3 implementation makes classic deauthentication attacks largely ineffective. WPA2, a protocol that served for over 20 years, is now officially obsolete, described as stale security milk due to fundamental architectural flaws like KRAC. Certification for new WPA2 devices ceased in 2020. Wi-Fi 6E and Wi-Fi 7 mandate WPA3, rendering classic tools like AirCrack NG largely irrelevant against WPA3 SAE networks. WPA3 introduces 2 fundamental mechanisms to overcome WPA2's key weaknesses. First is simultaneous authentication of equals, SAE, which replaces the vulnerable 4-way handshake and prevents passive eavesdropping. Second is protected management frames, PMF, which secures management frames against forgery and denial of service attacks, and is mandatory for all WPA3 connections. PMF drastically changes how clients react to deauthentication attempts. Without PMF WPA2, a malicious deauthentication frame immediately disconnects the client. With mandatory PMF WPA3, the client checks the frame and silently ignores unsigned or unencrypted deauthentication frames, maintaining the connection and saving airtime. Despite strong cryptographic protection, WPA3 is not immune. The most significant attack vector is the SSID confusion vulnerability, a logical flaw in the IEEE 802.11 standard itself, not the cryptography. This attack exploits the lack of mandatory cryptographic binding between the network identifier and the session keys, allowing a rogue AP with a different SSID to trick a client into connecting. Wi-Fi 7 802.11b, ratified in July 2025, introduces architectural changes to eliminate logical vulnerabilities. A key security innovation is beacon protection, a mandatory feature that allows connected clients to cryptographically verify the SSID and other network parameters after the connection is established. This is a direct countermeasure against the SSID confusion attack. The evolution of attack vectors requires an evolution of tools. The focus shifts from automated key cracking to high-precision monitoring and creating complex attack scenarios. Legacy tools like AirCrack NG are ineffective against WPA3. Modern monitoring tools like Kismet are used for passive reconnaissance. New platforms like Rogue AP frameworks are used for exploiting logical vulnerabilities, such as SSID confusion. The true battleground is the management infrastructure. Enhanced cryptographic protection at the 802.11 level forces attackers to target the weakest link, the centralized management infrastructure. The paradox of modern security is that strong WPA3 protection becomes useless if an attacker gains control over the WLAN controller or cloud management panel. New compromise vectors include web interfaces, Radius servers, and cloud services. A case study illustrates how controller compromise occurs through RCE in web components. A critical vulnerability, CVE 202.555182, in a popular web framework, allows an attacker to remotely execute arbitrary code on the WLAN controller's web UI. This leads to full control over the Wi-Fi network, including changing passwords and data exfiltration, completely bypassing WPA3 security. CISA priorities confirm that attackers are actively targeting network infrastructure components, not 802.11 protocols. Risk assessment should be based on real exploitation data. High-impact vulnerabilities include the SSID confusion logical flaw and remote code execution in management servers, such as those related to React server components and WatchGuard fireboxes. Strategic recommendations for red teams require a tactical shift. Change the focus from cryptography to logic. Instead of offline WPA3 SAE cracking, model SSID confusion attacks and use social engineering. Prioritize attacking the control plane. Conduct thorough testing of WLAN controller web interfaces, APIs, and Radius servers for RCE, SQLI, and other web vulnerabilities. Expand perimeter testing beyond just Wi-Fi to include adjacent technologies like Bluetooth Classic and BLE. Strategic recommendations for Blue teams demand decisive action to strengthen configurations. First, fully migrate to WPA3 and enforce strict protocols. Eliminate support for outdated protocols like WEP and transitional WPA2, WPA3 modes, which are the main cause of downgrade attacks. Second, implement Wi-Fi 7 protective mechanisms like activating beacon protection to defend against SSID confusion. Third, prioritize infrastructure vulnerability management, monitoring the CISA KEV catalog for critical vulnerabilities like CVE 202-555-5182. The future of wireless security involves AI and post-quantum cryptography. AI and machine learning can be used for proactive threat detection, anomaly identification, and analyzing RF signals. Post-quantum cryptography addresses the threat posed by quantum computers. The IEEET-GBT Working Group is already developing amendments to the 802.11 standard for integrating PQC-resistant algorithms for authentication and key exchange. The key takeaway is that Wi-Fi security is infrastructure security. Protecting modern wireless networks requires a holistic approach that includes management systems like WLAN controllers, cloud platforms, and server applications. The success of Wi-Fi security depends not just on the 802.11 standard, but on deep expertise in network infrastructure and web application security. Wireless security ends where the vulnerability of its controller begins.